Yeah. I'm Mahsa Safarkhani, PhD student of the SPIN-ITN 3.4, and I'm going to talk about array beamforming on ambient seismic noise correlation reveals repeating seismic wave in the CODA. First, I have a short, brief explanation about the seismic interferometry. Generally, this method has been improved our ability for the investigate Earth subsurface structures when we can consider the recording wave fields as a virtual seismic sources at any location when we have only receivers. So by cross correlations, we basically extract the coherent part of the wave field passing through two receivers. And actually, this asymmetric correlation reveals the violence of the homogeneous and uniform assumptions and contain main informations about where dominant seismic sources are. And also in this method, assume that the main contribution for the retrieved direct waves comes from the master stations. And in this strategy rely on that the later part of the correlation wave field. CODA waves contain the multiple scatter waves originating from the master stations as well. This type of waves actually travel long distances and dictated pixel by pixel of the Earth and contained valuable information and has been considered as a robust tool for velocity monitoring. So for this study, we want to investigate actually the originating of the CODA wave correlation wave field when we want to use the seismic interferometry for further studies like velocity monitoring. So for the data preparation, we consider 2 years continuous recording wave fields throughout the Grafenberg array in Germany and several master stations throughout Europe with different range of the interstation distance from the 300 to 2,000 kilometers. And for the retrieving the reference cross-correlation signals, we follow the basic and common technique as outlined by Benson 2007. And you see the location of the two master stations, OJC in Poland and BRMO in Italy, towards the seismic arrays, and also the retrieved signals regarding the primary frequency band. And as we can see, besides the diverging and converging correlation wave fields between the master stations and receivers, we have some strong isolated sources like North Atlantic oceans, which excite continuously seismic waves when we investigate and retrieve the signals correlations. So for localizing the For localizing the seismic sources, actually we use the seismic noise or seismic array beamforming. Very short descriptions, first introduced by Rosa and Thomas, 2002, and estimate with this method, actually we able to estimate the direction of the arrival, azimuth and slowness for the seismic waves crossing the array. When we want to use actually the beamforming for the noise correlations, we expect that the diverging correlation wave fields from the master station should be monitored in the positive lag side of the signals correlations, and vice versa, the converging part of the correlation wave field to master station has been monitored in the negative lag time side. And so for the doing the beamforming, for doing the beamforming throughout the cross correlations, we are able to see the main contributions of the seismic sources regarding the arrival time of direct waves and later part of the CODA of the correlation wave fields. So we dividing the correlation wave fields to the 10-minute window and doing the beamforming. Regarding the results, we see for the direct arrival, as we expect, the most contributions of main sources comes from the master stations in the positive and negative elapsed time side. However, when we apply for the further part of the correlation wave fields further and further, we see that the result or story for the coda wave of the correlation wave field is different, mostly generated by the microscience waves, which continuously seismic waves throughout the correlation wave fields. And these results are the same for the rest of the master stations, and for the, actually because of the shortness of time, I just showed the another one, BRMO in Italy, and we can see the result for this master station as well. And totally, you can see the agreement of the beamforming for the raw data recorded for the Graphenberg array, and later part of the beamforming actually for the OJC and BRMO in positive and negative elapsed time site. In conclusion, isolated north sources may have significant implication for the monitoring applications and that impact the coda of the correlation wave fields. And while the direct wave contributions only interfere for the actually certain station pair geometries, coda wave correlation contributions may overlap and interfere for the larger range of the geometries. And we know that the origin of the coda wave field illustrates its spatial sensitivity. So we should actually, if we misattribute the origin of the coda wave, we have bias to our results. So it's very important to better understanding the nature of the seismic waves which compose the coda correlation wave fields. If you are interested in our results regarding the secondary macroseism and frequency band, and also some simulations regarding the isolated north sources and repeating the direct seismic waves, here you can find our submitted paper, and thank you for considerations.